Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on satellite communication. This video, I mainly will focus on the frequency that is actually allocated for satellite service. From here, you can actually see 7 bands of interest. We have the L band. The L actually stands for long. We also have the S band. S actually stands for short. We also have the C band. C actually stands for compromise. We also have the X band. This X actually stands for extreme. Next will be the KU band. KU stands for K under. We also have the KA. The KA actually stands for K above. And last but not least, we have this BEE band. Okay, so this video, I will discuss all these 7 bands. What will be the frequency range? What will be the typical use and their key feature? So this will be the objective of this video. This is my email. If you have any question regards on this discussion, please drop me an email. Or if not, I actually prefer you guys to send me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, it's free. Please help me press the like button now. For those who are new to this channel, and if you want to support me, please consider to subscribe and turn on your notification bell. Once again, thank you so much for your strong support. From this diagram here, you probably can see that there are actually 2 frequencies. Okay, we have the uplink and also the downlink frequency. Okay, so for satellite communication, they in fact use the electromagnetic spectrum frequency to transmit signal to an orbiting satellite, which is known as uplink. So from here, you can see that this is actually the satellite Earth station. They actually send a uplink to the orbiting satellite. So the orbiting satellite receive the signal. Okay, they will amplify the signal and then later on retransmit to a ground station. Okay, so when the orbiting satellite sent to the Earth station, this is what we know as downlink. Allocation of frequency to a satellite service, in fact, is actually very complicated process that they actually require international coordination and planning. Okay, so this is actually carried out in accordance to the ITU, International Telecommunication Union. Okay, so in order to implement this frequency planning, the world is actually divided into 3 regions. Region 1, Region 2, and Region 3. So Region 1 mainly cover the Europe, Africa, and also Mongolia. As for Region 2, mainly cover the North and South America and the Greenland. The third region basically cover the whole Asia, okay, except Region 1 area, okay, which is Mongolia, Australia, and the Southwest Pacific. Okay, so basically this is actually a diagram to show it to you how the frequency is planned for the whole world. Mainly you can see that there are actually 3 regions. Next, I'm going to share how the frequency is actually allocated and how they actually manage the structure. In the whole world, basically will be as an international level. As I mentioned that this is going to be managed by ITU. Okay, so basically ITU actually governs the whole global spectrum usage and coordinate frequency assignment for different service through its radio regulation. Coming to the national level, for example, I'm actually in Singapore, which is controlled by IMDA. Okay, so basically this is under the national regulator. Okay, as I mentioned, IMDA, they in fact will allocate spectrum for local use and they offer through the licensing, auction, or direct assignment. Okay, so basically this is how the frequency is allocated. Firstly, controlled by ITU, and then based on different country on the national authority, they actually will reassign the frequency usage. From this diagram here, you can see that the different types of service that is actually provided by the satellite. We have this fixed satellite service, okay, mainly used for telephone and TV signal transmission. We have this satellite in terms of broadcasting. Okay, so basically this is actually direct broadcast to home. we also have the mobile satellite service, okay, mainly for land mobile, maritime mobile, or even aeronautical mobile. Next, we have this navigator satellite service. This includes the GPS. Last but not least, we have this meteorological satellite service. This is mainly used for search and rescue work. Before I continue, guys, this is very important for me. If you have learned something from this video, I urge you to help me by like this video. Again, I hope you can support me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. Let me go through the major satellite frequency band. The first one will be long band, L band. Okay, so the typical frequency range will be between 1.5 to 1.6 gigahertz. In terms of the usage for mobile satellite service, from this diagram here, you can see that all these devices, they are actually allowed to move from place to place. This L band is also supporting GPS, global prediction system. Next, come to the feature. Okay, so for L band, they in fact has good penetration through clouds, rain, and building because of lower frequency. Because of also low frequency, it actually has lower data rate. Next will be S band. S actually stands for short. Okay, so S band actually utilize frequency from 2 to 4 gigahertz. Let's come to the use case. S band is mainly support weather satellite. It also support mobile communication in order to have some telemetry and tracking purpose. Coming to the feature, okay, because of higher frequency as compared to L band, so therefore S band in fact has a moderate bandwidth, which means that they can carry more data. They are also reliable in various weather conditions because the frequency doesn't increase a lot. Okay, basically almost 2 times as compared to L band. C band, C actually stands for compromise. So they actually distinguish the uplink and downlink frequency. From here, you can see that the uplink frequency is between 5.925 to 6.425 gigahertz. As for downlink, the frequency is around 3.7 gigahertz to 4.2 gigahertz. The use case for C band, it is mainly used for fixed satellite service. Okay, for example, our home, the location is actually fixed. So this C-band mainly support fixed satellite service for TV broadcasting and also for long-distance telecom. Coming to the feature of C-band, it is also very resistant to rain fade. However, it actually requires a larger antenna, as you can see from here. So this is actually for C-band. Next will be X band, extreme band. Okay, so basically the frequency for X band is between 8 to 12 gigahertz. This frequency band is mainly reserved for supporting military. So the use case is they actually support military satellite communication and also radar and space research. Coming to the feature, since it actually used for military purpose, hence it will be less crowded and more secure, and in fact, they are actually control access. So this is actually for X band. Next will be KU band, K under band. So the typical frequency is from 12 to 18 gigahertz. So from here you can see that it actually has an uplink frequency around 14 gigahertz, while for the downlink frequency is between 10.7 to 12.75 gigahertz. Coming to the use case, it is mainly for direct to home TV. Okay, so basically you can see that these are end user. Okay, for example, this can be receiving TV program from the satellite. It is also support BSAT network. Coming to the features, okay, so because of higher frequency, okay, so the antenna size is actually reduced. So it actually has a smaller dish antenna. However, it is actually more sensitive to rain fade as compared to C band. So this is actually for KU band. Next will be KA band. Okay, so K above band. Okay, so basically for KA band, they in fact has a higher frequency as compared to Ku band. So the typical frequency allocation, okay, for uplink will be between 27 to 31 gigahertz. As for downlink frequency, typically is from 17 to 21 gigahertz. Coming to the use case of Ka band, so basically they support high throughput satellite. As you can see from this diagram here, okay, because they are able to do some form of beamforming, so therefore they can actually support high throughput satellite. It also mainly support broadband internet, for example, SpaceX. Coming to the key feature, okay, like I mentioned earlier on, firstly, because of high frequency, and also they are able to concentrate in a beamform, so therefore they can support very high data rate. However, okay, the bad point about Ka band is they are strongly affected by rain attenuation. So this is actually for Ka band. This will be my last slide for today's discussion. V band. Okay, so basically this is actually extreme high frequency. Throughout the different major satellite frequency band that are actually introduced, you can see that the frequency keep on increase and increase. Coming to the use case of V-band, in short, is actually next generation of satellite system. Okay, so nothing concrete, so-called confirmed in terms of the spec. However, you can imagine that they can support extreme high capacity. And again, because of the high frequency, it is actually very significant to the atmosphere absorption. Okay, so this is what I have for this video. In this video, I have introduced the 7 types of band. These are all the major satellite frequency band. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.